webinars on key aspects of the World Energy Outlook released in October this year. Yesterday was a deep dive on the energy-related impacts of the coronavirus crisis. And today we focus on the outlook for electricity. Electricity is at the heart of modern economies, a point which has been underlined this year by the global pandemic. Electricity is also the leading edge of clean energy transitions, with a variety of commercial low-carbon technologies, from wind, solar PV, and other renewables, to nuclear power and carbon capture technologies. My name is Brent Warner. I'm the lead for power sector modeling and analysis for the World Energy Outlook. And today, I'll be your host and moderator. We will first have a scene-setting presentation from my WEO colleagues, Yasmin Arslan and Tim Goodson, who will describe our main findings on the outlook for electricity. Then we will turn to each of our three panelists. We're very fortunate to have with us today some of the leading minds on electricity from around the world. We have Dr. Doug Arendt, the Executive Director of Strategic Public-Private Partnerships at the National Renewable Energy Laboratory in the United States, which works to transform energy economies at speed and scale across the globe. Over the past 30 years, Dr. Arendt has published extensively on topics within clean energy, renewable energy, power systems, natural gas, and the intersection of science and public policy. And thank you, Dr. Arendt, for being with us so early. We also have Kartik Gunnasan, the power sector lead at the Council for Energy, Environment and Water, a not-for-profit policy research institution based in New Delhi, India. His research focuses on all things energy, but particularly on the future of India's power system and improving air quality in Indian cities, one of the biggest environmental threats facing citizens, both rich and poor. Thank you, Kartik, for being here. We also have Professor Dr. Jochen Preussel, the Senior Vice President of Hitachi ABB Power Grids and Global Head of Market Innovation. Prior to his current position, he headed ABB's Smart Grid Sector Initiative. Dr. Preussel is also an honorary professor at RWTH Aachen University. Welcome. After initial remarks, I will then moderate a Q&A session with the panel. If you have questions for our speakers, please email them to weoweek@iea.org. We will close today's webinar in about 1 hour. So I'll now pass the floor to Tim Goodson and Yasmin Arslan for the introductory remarks.
Thank you very much, Brent. Thank you all. So I'd like to begin today's scene-setting presentation by looking at the outlook for electricity demand. So while demand fell markedly during initial lockdowns earlier in the year, as the services sector and many industries were closed, on the whole, global electricity demand has been relatively resilient to the COVID-19 shock. Electricity has fared far better than other fuels in 2020, with demand nonetheless expected to decline by 2% across the year. And this is compared to a 5% decline in final energy demand. And in fact, in many economies, such as China, for example, electricity demand has already returned to pre-COVID levels, driving a year-on-year increase in demand in certain cases. While in Europe and certain other economies, the recovery is being delayed by further lockdowns. Now, if we look forward, electricity demand returns to growth in all of our scenarios in the early 2020s, taking an ever more central role in meeting energy needs and outpacing demand growth for other fuels. So in our stated policy scenario, a scenario which assesses the impacts of enacted and announced policies, the share of electricity in final energy demand increases to 24% by 2040, up from 20% today. While in our sustainable development scenario, a scenario that achieves multiple energy-related sustainable development goals, this share rises to above 30% by 2040. Now, coming back to the trends in the stated policy scenario, China leads the growth in electricity demand, with demand almost doubling to 2040, adding the equivalent of twice the demand of the European Union today. However, it is India that sees the fastest growth, increasing at an average of 5% annually over the coming 2 decades, and overtaking the European Union as the world's 3rd largest power system before 2040. Now, globally, demand in 2040 is 50% higher than today in our stated policy scenario, reaching nearly 35,500 terawatt hours. And without improvements in energy efficiency over the next 2 decades, demand would have been a further 20% higher. Now, turning to the sources of demand growth, traditional sources of demand such as electric motor systems in industry and household appliances continue to be the pillars of growth going forward, especially across developing and emerging economies with high levels of income growth and industrialization. Nonetheless, the face of demand growth is changing with space cooling needs, digitalization of our economies, and increasingly the electrification of transport, all emerging as major drivers of future electricity demand growth. So I'll now pass to Yasmin for the supply side perspective.
Thank you, Tim. So one key question we have now is that how do we meet those increasing electricity needs you just showed? So I suggest now that we have a look at the supply mix, and this is where we are witnessing a profound transformation on how electricity is produced. So over the last 2 decades, coal was clearly dominating, with electricity generation increasing more than any other source, as you can see. But change is already underway. Renewable sources are growing fast with sharp declines of cost. In particular, solar PV is now the cheapest source of electricity in most countries, and it has been the most built power technology over the past 3 years. We are definitely entering a new area, and solar PV is becoming the new king. Looking forward, we continue to see a steady market growth for solar PV. At the same time, coal output declines under stated policies. Solar PV becomes the primary mean of meeting electricity demand growth during our outlook, and generation increased by well over 4,000 terawatt hours over this period, more than coal in the past. What drives this growth? Well, solar PV cost declines continues, policy support is widespread, present in over 130 countries worldwide, and our latest analysis really highlight the importance of cheap financing availability. In the leading solar market, financing costs are extremely low, and it reflects very low revenue risk under prevailing policy framework. We are seeing low rates in Europe, below 3%, below 4% in China and the US, and below 6% in India. We see also that other low carbon technology grows strongly, including nuclear, but also wind, onshore and offshore. And the potential for growth is even larger under our sustainable development scenario. In that scenario, global solar PV market takes off. 8,000 terawatt hour increase, which is the equivalent of 12 times the generation we observed in 2019. And these are major transformations that put the power sector at the forefront of clean energy transition. But at the same time, it has implication on how power system needs to operate in the future. And with that, over to you, Tim.
Thank you, Yasmin. So the central importance of electricity to modern economies becomes clearer every day during this global pandemic, as electricity has supported widespread behavior shifts while keeping the lights on, information flowing, and health services up and running. So all of this places electricity at the heart of modern energy security, and flexibility is a cornerstone of electricity security. Now, one point of consistency across all our WEO scenarios is that flexibility needs are set to rise. For instance, in the stated policy scenario, flexibility needs are set to double globally out to 2040. Now, what do I mean by this? Well, one way to measure flexibility needs is at the hourly level, specifically the hour-to-hour ramping needs to fully integrate wind and solar PV and respond to changes in demand. So here you see those needs in 2019 in 4 major regions, with each dot representing each hour of the year. So across the European Union, the largest upward change in dispatchable output from 1 hour to the next was around 20% in 2019, occurring when demand was rising and both solar and wind power declining. But in the future, flexibility needs will be much higher. The changing shape of electricity demand and the strong growth of solar PV and wind power are together increasing flexibility needs in power systems around the world. Average hour-to-hour ramping needs almost double across most major power systems to 2040 in the stated policy scenario, with much higher increases in some systems. For example, in India, certain hours will see the need for dispatchable sources to ramp up or down by well over 50%. Now, the good news is that there are many flexibility sources available, from power plants to electricity networks, storage technologies, and demand response measures. Now, today, coal and gas-fired power plants are the main source of flexibility in many systems, with additional major contributions from low-carbon sources like hydro and nuclear power. Looking ahead, storage and demand-side response could play central roles in flexibility with the right policies and regulations. And underpinning all of these sources are grids. So I'll pass back to Yasmin for more on grids.
Thank you, Tim. So indeed, all flexibility sources are needed, but let's focus on one key aspect of power infrastructure, grids. So we're talking about millions of kilometers of lines and other network infrastructure that are needed to support electricity growth and electricity transformations. They are really critical to integrate the rapid growth of variable renewables. We can say that grids are really the bedrock of clean and secure electricity future. So over the next 10 years, required grid extension totals 16 million kilometers in the steppes. It's an increase of 80% compared to the past decade. And to give you a sense of scale, this means 400 times circling the globe. And to expand and digitalize grids, a key step to support changing power system, well, investment levels must also step up. But the problem is, and we've seen it in 2020, that depressed revenues for grid operator due to the pandemic are creating risks for this step up of investment and the timing of these investments. Some of the largest power systems in the world have seen significant reduction in these revenues in the first half of 2020. And revenue reductions have been recorded everywhere around the world. This reduced cash flow to grid operators would lead to difficult choices and could lead to delayed or inadequate investment with significant implication for electricity security. What does it mean? It means that regulatory reform may be needed to ensure sufficient cash flow and timely grid investments. Otherwise, this could put at risk not only electricity security, but the pace of clean energy transition, clean electricity transition. So to conclude this quick snapshot Tim and I just gave on some of the many aspects of electricity demand and supply, I would say that this illustrates the many challenges and opportunities ahead that we are really looking forward to discuss later during this session. With that, over to you, Brent.
Thank you, Yasmin, and thank you for those introductory remarks. So I think this gives us a feel already for the kind of profound transformation going on in electricity and electricity supply, but also on the demand side and the geography of demand. I'd like to now turn to our panel. First, to Doug Arendt from the National Renewables Lab in the US. We've seen the picture here, an element of power system flexibility, and that it will be a cornerstone of electricity security, especially during clean energy transitions, and certainly this will be true in the United States. I wonder if you can provide some perspective and comments on important areas of agreement of analysis that NREL has done, and potentially if any additional or complementary points in addition to what's been presented already. Thank you.
Yeah, thanks, Brent, and thanks everyone for having me. Let me start with a couple of quick reflections from our work at NREL, and then I'll pointedly make some comments on your question. Tim, if you could go to the next slide. I just want to remind folks of what NREL is. One of 17 national laboratories in the United States. We are solely focused on energy efficiency and renewables, and have been for more than 40 years. We're currently nearly 3,000 employees, many of them focused on explicitly power generation technologies, but increasingly so on system integration and advanced analytics. And of course, we have a campus where we actually test and do experiments on these futuristic energy systems, or the systems that are evolving for our energy future. You can see a quick picture of that in the background. We also work very intimately with industry and with partners around the world in more than 90 countries. And so I'll try to provide a brief glimpse into some of that work, both across the US and across the world. Tim, if you could go to the next slide, please. Click through on this because it builds. I wanted to show you a video from actually work we did a few years ago with the California ISO. And what you're seeing here in this video is the output of a 300 megawatt photovoltaic plant in California that is receiving what's called auto generation control signals from the system operator. And what you see is the requested signal in blue and the following signal in red. And what was allowed was a 30 megawatt window. And this big dip that you're seeing in the middle is in fact a cloud going over it. And with advanced forecasting and knowledge of that, you can actually see that both the system operator knew it was coming and was anticipating it, and the output actually calling for that was decreased consequently, as well as the following of it. The interesting piece here on the takeaway, and you can see the reference there, is that this is an example of a modern photovoltaic, and we've done the similar on wind plants and hybrid plants, providing advanced grid services to system operators. They actually do it at much finer quality, is a better way to say it, than many of the thermal generators, which have built-in inertia and a slower response time. So if you click to the next slide, I just want to summarize a bit, and here I'll get to Brent's question in terms of what's happening in the US. This is a slide we put together now a few years ago that articulates conceptually the different sources of flexibility, and many of them that the IEA colleagues just talked about, with a particular focus on flexible generation and transmission. Clearly in some of those photos and slides, we saw the importance of batteries, which are well modeled these days in multiple different configurations. But there are two other sources that I think are worth conversation about. The first is, of course, what's in the green column here, which I just showed you an example of, which is that renewable resources, either directly or independently configured or in hybrids, can in fact provide many, if not all, of these grid services. In fact, we've recently released reports on black start from inverter-based resources and other critical grid services as well. And the second one, which we have not talked about much, but I think deserves an interesting conversation, or at least some Q&A, is really what's happening on the system operations side. This includes advanced forecasting, scheduling, sub-hourly market designs, And of course, there's a whole other bucket which is not on this graph, which is really about market design and market evolution. So reflecting on this, Brent, and your question, the answer really is across the United States is we're seeing a wide variety of knowledge being gained with instantaneous penetrations of renewables exceeding 80% in Texas, California, the Southwest Power Pool, and increasingly system operators and utilities across the country with diverse resource bases, or their utilities commissions or legislators committing to 100% clean or a net zero target, most of them with significant confidence that they can achieve the bulk of that with renewable based configurations, not necessarily 100% renewable, but renewable based configuration. So very consistent with the insights that I think are coming from the IEA, and the economics are playing out to support that as well. So let me stop there with that quick summary and look forward to the panel discussion. Thank you.
Thank you very much, Doug. Very interesting insights already to add to the picture on flexibility. And I think that's a very important point, that flexibility is a single term, but encompasses many services and many of these aspects. So it's actually a very large field of analysis, and an area that we will all need to do more work in the years ahead. Thank you. Next, I'd like to turn to Kartik Gunasan from CEW in India. Kartik, India's leadership has set very ambitious targets for the scale up of renewables, while also aiming to limit the use of coal-fired power. What are some areas from your view that have exceeded expectations, and maybe some areas where progress has been a little bit more limited to date?
Thank you so much, Brent, for having me on this, and I'm really glad that there's a focus on India on this esteemed panel. Of course, as Tim mentioned, India does have a place there primarily because of the large growth in demand that we're likely to see. But I'd like to point out to everyone listening here that at no point does India's consumption of coal, for instance, go beyond a fourth of what China did at its peak. So we are still looking at a system that at no point really, explodes in a way that, I think is captured in popular perception, that India is this, this giant waiting to grow its energy consumption. It is actually a paltry. So we should keep that in mind as we discuss this. In terms of what has actually worked for India, I think, if any presentation that you go to made by an Indian presenter from 2015, you will see this magic figure of 175. So I think it's become like this mantra that everybody's chanting, every day, right? And believe it or not, 3 years ago, everybody was like, are we going to get there? Does it look likely? And now we're 2 years away, and we're probably going to get to about 160 or so, right? Which is the great part. So a target was set, right? A target was set, which seemed ridiculous at the time that it was, but it showed the aspiration and the ambition that the administration had, despite the fact that there was still a lot of developmental needs for the country. And through, I guess, you could call it hook or by crook, right? They've sort of almost managed to deliver on it. And I think that is where the challenge really lies, right? In the way they've got there. So if you look at it, it has all been because there is this mandate to get to 175, because it's now a matter of, I've committed, now let's better deliver, because this administration is going to be in power when that deadline comes, right? And they made that declaration in 2014 or 2015. So what they've basically done, they've got this company, which is called the Solar Energy Corporation of India, and they've basically gone out and mastered the art of, calling reverse auctions for capacity build out. And, I think the rest of the world wants to figure out how to make this work at that scale, which is great. But the problem is that they've auctioned out a lot of capacity, especially in the last 2 years, some phenomenal numbers. But there's a lot of capacity that's been auctioned out where there are no takers ultimately for the capacity itself. The way this works is there is an intermediary, which is the Solar Energy Corporation. You've got the discoms on one side, you've got the developers on the other side. And developers basically respond to this call and say, you know what, I'm going to build out, and this is the price at which I'm going to build out. And whoever sort of quotes the best rates for the whatever the terms are, they win it. And we've got right now about 20 gigawatts worth of capacity that was contracted out, for which there are no takers on the other end. So the Solar Energy Corporation is basically stuck with these. And if there's no takers, what happens? You basically renege and you tell the guy, I'm sorry, there's no takers here. You know, all that money and process that we spent in getting the capacity contracted is not going to happen. It sends bad signals because, you know, then developers further on aren't going to expend the effort in sort of really coming up with it. And why aren't companies taking up, distribution utilities taking up the capacity? Well, there are a couple of challenges. The reason why this is so attractive in the first place is because there's a payment guarantee. And that, as you know, is the biggest challenge in economies like India, where, you know, utility sort of, you know, finances have been a problem in, you know, developers coming on board. So given that there's a payment guarantee, it means anybody who signs on better pay up to the Solar Energy Corporation, right? And I think COVID, unfortunately, has not done anything good for the finances of utilities because, you know, consumption is down from key sectors. Payment rates have gone down primarily because of, you know, a lot of waivers that have been given, and, you know, there's relaxations on when people can pay up. So this year is definitely not looking good. And I know, I think there have been a lot of studies that have looked at when will things recover. Well, even though there seems to have been a near V-shaped recovery, Tim, in terms of loads going right back, right? But in terms of the money that the discoms are going to see is nearly not there yet. So because of this, what's going to happen is that there's going to be this buildup of capacity from there. And as a result, what we're going to see is that there's going to be this tentativeness in the market as to whether or not, you know, should I bid for more projects? There are lots of interesting projects. I mean, and a lot of the technologies that Doug has already spoken about are already sort of being put in place. So for instance, we had some really good build outs of contracts for storage-based bids, right? For storage to supply round the clock, right? So they're trying to do lots of innovations, but they're stopping short of doing that ultimate innovation of moving the Indian bulk procurement system or market to a true market. It's still going to be through PPAs, right? Bilaterally contracted stuff, which I think precludes us from getting the kind of efficiencies that we see in the rest of the world. And I think that is ultimately the biggest challenge that India sees. And I'll just say one last thing. One of the problems with having this, you know, this mission-based approach is, you know, they want to get all of this capacity on board, but the problem is you've already got this massive pipeline of coal-based capacity, which was built out, you know, through the good part of the last decade, which is not very old, which is already paid for, right? Even though it's a sunk cost and you should be looking at, you know, future. The thing is that, you know, it's very difficult to get utilities to think of it that way. So they're still sort of, you know, holding on to the earlier PPAs that they've signed. Even if the variable costs are high, they're not retiring older plants. And as a result, I think there's this backlog of renewable energy projects that are not really able to come on board. So unless we can address that issue, I think it is likely that we will run into sort of operational hitches, even though on paper, we may have capacity that's built out with nobody really taking the power from there. So let's just hope we don't get into ghost power projects and stuff. The country definitely cannot afford that. Yeah, I'll leave it at that. Thank you.
Thank you, Kartik, for already raising these important issues on, you know, it's much more than just getting the capacity in place. It's about these larger systems. That also goes to a comment from Doug about the having the market designs in place. And it's certainly something I want to come back to in the Q&A and open discussion. So thank you, Kartik. I would now turn to Jochen Kreisel from Hitachi ABB Power Grids to come back to the point on the importance and the centrality of grids in the overall clean energy transitions. Clearly, they're supporting them. And from your perspective, it would be interesting to hear what some areas that you see are receiving enough focus, and some areas related to grids that risk falling behind. Thanks very much.
Yeah, thank you very much for also having me on this panel. As has been said during the introduction, I'm in charge of what we call market innovation, and that's a pretty recent role, and we introduced it to contribute to this ongoing transition, you might say reinvention of the world of electricity. So we are running long-term studies on how this future world could look like, and of course, being a technology provider and, well, having contributed to making electricity happen more or less from the very first days of electrification, we have an ambition to make it happen and to find out what needs to be done to make it happen on the technical side. But we will also see it's not only technology. Maybe we can go to the first slide, next slide. So first, of course, we looked at power systems, at electricity. And we usually summarize the ongoing transition with this slide, which some of in the audience may have seen before, which is basically dealing with introducing, ramping up variable and distributed renewables. That's basically the challenge. And as we heard before, PV is the new king. Well, this is certainly one of the most decentralized and scalable technologies that we ever have seen. So it can be deployed at large scale as well as very small scale. And we will see all of that. And that results in a different way to operate and coordinate power systems, which, independent from how they are organized, whether they are unbundled or integrated, they are always an integrated technical system. And the more we talk about even expanded grids, the more integrated they are. So one of the challenges is to find out how to operate these systems. And the other one is, of course, also how to get all the services we need to run. And I'm very happy that Doug elaborated a lot on that already, so I can shorten that and say, well, technology, to our experience, will not be the bottleneck. So far, we have seen a lot of encouraging demonstrations, pilots, and very often in the meantime also real-life applications where renewables are more and more providing the auxiliary services that used to be provided by conventional generation. So we are very confident that that will not be the bottleneck. But what we do see is that the regulatory and legal environments very often still do not challenge the new players in provide or offer the opportunity to provide such services. And I think that's one thing that needs to be adjusted as fast as possible. We used to call them, renewables have to become adult, so they have to take all the normal obligations that we are used to receive from the generation system. And we don't have doubts that this is possible. But very often the frameworks somehow exempted renewables from providing these services. And then you don't need to be surprised that they will not provide the services. If you don't ask for them, why should they? So that's one thing. Legal and regulatory frameworks need to be designed in a way that they are challenging the renewables and prepare the systems to be run on 100% of variable renewables, which in the end is our objective. Then let's go to the second and last slide, the next and last slide. Electricity is not all. And sorry for this busy slide, but now the world becomes even bigger. In fact, electricity until today is maybe about, depending where you go, a quarter of the total consumption. If we're talking about a climate neutral energy system, we need to address the other sectors as well. And we heard about the importance of electrification, and of course we agree with that. Our analysis show the same. So, but they also show that, at least from an end use point of view, it will not be all electric. We will have sectors that will be difficult to electrify, where it's not efficient or maybe even not feasible. Still some doubts whether we will see direct electrification in aviation, for instance, or in some chemical industries. So there will be a sector requiring molecules, and there are a lot of talks about hydrogen at the moment. So hydrogen may be the molecules. So we will have a molecule-based sector, both as feedstock and as energy for some sectors, but we also need to think about where will this energy come from. And if you want to have it green, the likelihood is that in the beginning of the process chain, there is electricity because it's coming from the new king, solar PV or wind, is very high, not to say 100%. So on the primary supply side, it's most likely a fair assumption to think about a full electrified system or mainly electrified system, whereas at the end energy, secondary energy side, not. But that defines the paths we should look for. So we have to look for direct electrification wherever possible and feasible, because this is the most efficient way to do it. If we assume at the beginning there is electrification, we should strive for avoiding conversion steps simply because of efficiency. And even if solar PV becomes very cheap, we should not forget there's another resource that, at least in the industrialized, densely populated regions of the world, is becoming more and more scarce, and that's space. So also renewables are not for free, even if they economically become increasingly cheap. There will be space scarcity, and we see that already, so efficiency matters, certainly. That is the argument for a direct electrification path of sectors that are not electrified today. I think the most visible at the moment is private transportation, individual transportation, as well as basically also parts of public transportation. But we also have to think about how to turn the remaining sectors into climate neutral sectors by switching them to green molecules, gases. So I think one of the challenges we have to deal with is to understanding that balance, and also to understand a most likely future division of world. This molecule part of the system, which you see on the lower side, on the lower part of the graph, has the advantage that it can be set up as a truly international market. So it can become also the flexibility backbone of a global energy system, whereas in regional dimension, we will most likely see even more electrical interconnection. And I think that was also said before, and of course we're pleased to hear that the grids are so important. We agree, our analysis is confirming that, so we will see more regional interconnection. Sitting in Europe, for instance, we assume that there will be more interconnections outside the European interconnected power system that we are used to neighbor states, but there will be a reasonable division of work between such enlarged interconnected power systems and interconnection through a gas or liquid energy system. So with that, I hope that gave enough food for thought and stuff for the following discussion. So I will stop here. Thank you very much for your attention.
Thank you, Dr. Korsel. That's yeah, certainly food for thought. And I thank you for bringing in the importance of more distributed systems. I think we'll certainly want to discuss that a bit as we move now into more open Q&A discussion. I remind those viewing, which at last check was more than 500 through our various channels, remind them that they can submit questions to us and for the panel at weoweek@iea.org. I would take up this point you mentioned about technology not being a limitation. I think there are various aspects of this that I would maybe dig at least one layer below. And maybe a first question to you on the grid side, whether the technologies are there today, or is this something that they will be there in time?
Good question. Thank you very much for this opportunity to clarify. Of course, we don't have everything that we will need because we never built such a system. But so far, look, we are on this journey for some time in the meantime, I would say roughly 20 years. And a lot of things have happened, and technology used to be there in time. And therefore, we are optimistic that we will be able to, as technology providers, to continue that journey. We have to ask for the right solutions at the right time. So, yeah, I think there are numerous examples. Some of them were mentioned by Doug on the controlling side. I could also add, for instance, we had discussions on, well, the acceptance of overhead transmission line is not always great all over the world. So about 15 years ago, we had a lot of talks about going underground, using cables instead. And at that time, the capacity of cables and the related HVDC systems, you have to go to DC if you want to go to long distance cables, was relatively limited. You wouldn't have called that truly transmission size. But we were also, in that case, I have to say, brave enough to anticipate the demand and push the development. And in the meantime, we are in the gigawatt range for cables. So if you see the opportunity, I'm confident that we can make a lot happen. And look where we are today in many countries in the world, high shares of variable renewables. If we remember the early days where even active promoters of renewables were saying, well, if we 10%, that will become a challenge. Those that were not so optimistic were talking about hosting capacities of 3 to 4%, and that's already challenging. In the meantime, we have added well, an order of magnitude more of that. We are at 30-50% in some countries of the energy, not of the capacity, and systems are still stable. So this is a tremendous success story from a technical point of view. Maybe not everything was economically most efficient, which is not only an engineering task, but we can't complain about technology so far.
Thank you, Dr. Kossel. And to take that up from to stay on the technology theme, I would turn back to Doug Arendt from NREL. Certainly this point on the renewable energy technologies themselves, we've seen these massive cost reductions, but also performance improvements for wind power, for solar PV. And then as you alluded to, I think the next question, or some of the next questions, are these flexibility services, system services. So to you, Doug, I wonder if you can highlight some of the key innovations we should be watching for in the renewable energy space.
Yeah, thanks, Brent, and thanks, Jochen, for further elaborating on a couple of the pieces on technology front. Where we are seeing increasing innovations come forward is actually across a pretty broad suite. So I mentioned many of the renewables or hybrid configurations offering, frankly, all of the critical grid services coming forward. And I think from an engineering standpoint, to just double click on what Jochen said, give the engineers the challenge and they will solve it. So, you know, I mentioned that, you know, we've got papers coming out from experimental work on black start, on inverter-based resources providing fast frequency response and grid stability services, et cetera. Increasingly so, when we look across this landscape, and particularly economy-wide work, which of course the IEA is very concerned and detailed on, is the interaction across sectors. So we see increasingly importance of grid efficient interactive buildings, for example, where we're seeing a evolution in smart controls, not just devices inside the buildings, but building management system controls, variable speed motors, et cetera. Innovations on one of the biggest growing loads in the world, which is comfort, shall I call it. Classically, we would call that air conditioning, but air conditioning is only one technology, right? You have things like swamp coolers. You have technologies like ice energy storage, which actually takes cheap power, makes ice, and then only runs fans and dehumidifiers. We have smart hot water heaters, things like that. So we're seeing a diffusion of smart technologies into other sectors, buildings being one of them, but then the other big sector where we're seeing a significant transformation is in mobility. And so here, the electrification of the mobility fleet, the requirements for charging stations, the ability, frankly, of the analytic community to create digital twins of you know, millions, if not hundreds of millions of individual trips, and then to explore what if scenarios of what future mobility patterns will look like with electrification, and to optimally place those electric charger stations, and then explore how to provide the power to those. Is that through distributed energy resources, microgrids, serving through the bulk grid? And of course, then you open up the set of questions of what does charging look like? Is it managed charging? Is it unmanaged? Is it, I'll call it grid friendly integration of electric vehicles, or problematic? And here we've got a whole suite of solutions. And in fact, other colleagues at the IEA have looked with ourselves and many others on this electric vehicle power system interface. And there's some very keen insights that are coming forward as well. So to, you know, step back and reflect, it's not just innovations within the power system, I'll call it the classic generator system. It is innovations across the interfaces with different sectors, which we have classically seen as, I'll call them load sectors. but increasingly they also become sources of flexibility for us. And we have to more holistically manage across all of those. Thanks, Brent.
Thanks, Doug. I think that's a great point here of, and part of why even the naming of today's session was on electricity and not sort of electricity supply or electricity demand, because I think increasingly we're actually, that line is blending, is disappearing to a large extent. And maybe to bring in Tim here on this point of sector coupling and particularly demand-side response, which you mentioned as one of the important sources of flexibility coming down the road, highlighted then by Doug through other comments. So I wonder also for those listening, I mean, some of the intricacies or the details around demand-side response and its potential role in providing flexibility services. Is this something that we see kind of universally available, in the United States, in India, in Europe, or is there more to consider here?
Yeah, thanks very much, Brent, and thanks, Doug and Joachim. Really important points that I appreciate there, and especially bringing up the point of, for instance, in the air conditioning example, looking at our need is for comfort, not for an air conditioner to be running with a given electricity load. And if we apply and extrapolate that to all the other end uses, then we really see that there's so much potential there, and we can't really, it's difficult to overestimate the potential that the demand side resources can play in sort of providing flexibility into power systems here. And so a lot of the work that we've done at the IEA has been trying to quantify that potential that exists for demand side response, or all loads in general, to provide these sort of services, and understand what end users have the highest potential to be providing such services, and how relevant this is for different power systems. So Brent, to come to your question, we look at major power systems such as India with a completely different load profile compared to the European Union, for example. And so we'll nonetheless see that it's fairly common that across most power systems, we're in the order of a 1/5, 1/6, or even a little bit more of annual electricity demand could actually be shifted in one way or another to provide flexibility services to the grid. So for instance, if we're looking at the European Union, it might be storage water heaters that can be shifted in time, because as a consumer, all I'm interested in is having hot water when I turn the shower on. Or if we take the example of India, then we have a huge demand for agricultural pumping. And so this represents just a great resource for flexibility potential if we start shifting that profile in time. And then obviously there's electric vehicles as an emerging source of potential flexibility. So how we decide to charge those vehicles is obviously incredibly important in terms of the potential implications on power system operation. But if I come back to a point brought up in the slides that we showed, then in our projections in the stated policy scenario, we have demand side response still playing a relatively small role in actually providing flexibility services in 2040, despite this enormous potential I'm talking about. So obviously that's indicative of some important challenges in actually bringing this potential to market and making it useful for power systems. So I think we brought up a lot of important points there on say the role of smart controls. And so having appliances that can be remotely controlled, that remove the need for consumers to be taking individual action every hour to shift their loads. But what's really important in this respect, and this is a message that the IA always tries to bring to the table, is the need for ensuring a level playing field in electricity markets so that demand side resources can contribute in the same capacity as supply side resources, and ensuring that given that much of the potential is small distributed loads, that these loads can be aggregated as necessary to then be able to participate in wholesale markets. And obviously we've also got to be educating consumers as to the possibilities that their loads can play in these markets, and providing these consumers with the right incentives to encourage them to participate. So clearly that highlights that there's a major role for policymakers in terms of market design, in terms of consumer tariff design, and many other steps to take there, such as, for instance, legislating or encouraging the adoption of smart appliances. So I think on the technology side, we've definitely got the potential there, and we've got the technology coming into the market, or if not already present, but there's still quite a bit to be done on the regulation and the policy design.
May I add
Sure.
one aspect to that? Because one thing that we saw is we are talking about power systems in future that will have to work different from the past, and we heard a lot of examples already. We have to integrate the demand side. We also have to integrate the highly distributed generation side, millions instead of a few hundred active elements in the system. So we certainly need to sort of, let me call it a vision or a concept. Sounds a little bit more pragmatic, how to make that happen technically, and then we have to roll out these technologies. And that means, well, regulation and legislation in the past had the task to ensure that a proven technical system continues to be operated properly, which was already challenging enough if you look at the history of regulation. But now we are talking about regulating a system which we even have not yet built. We even don't know how to build it. And we need to agree among all the actors how to do that. I said technology is not the bottleneck, and I continue saying that, but nevertheless, we need to agree on which technologies we want to use, where, and how they should interoperate. So that means, and regulators needs to reflect that. And the short consequence of this pretty long explanation is regulators, operators, and the users of the network, and maybe also technology providers have to do that jointly. They have to run that discussion, because no player alone has all the knowledge to do that. Regulators cannot be expected to have a technical concept in mind and then develop the great regulation ensuring that it will happen. On the other side, technology experts most likely will not create the greatest regulation scheme to make it happen. And that's a new element. We are hunting somehow a moving target, and we can only do that jointly.
Thank you, Dr. Kreuzl. I mean, I think this is a very important point of this connection between the technology and the regulation, and something we've been approaching from both sides, certainly. I'd be interested to bring in Kartik Kamsan here on this discussion in particular, and this issue going in India, and how some of those discussions are happening or not between the technology developments that are needed for tomorrow's power systems and the market regulations and frameworks that are also needed to make that happen.
Yeah, thanks. And I felt a little out of place in some of these discussions, primarily because I think, it's a mishmash of challenges that India faces, right? Because, we have one foot in this future of the electricity system, and we have probably more than a foot in legacy issues of the electricity system as well, right? So we're talking about, we've added close to 40 million consumers, right, in the last 5 or 6 years, right? So which means that, and you're talking about people who don't have the experience of using electricity, who are paying for it, and who don't understand sort of, what happens when you pay for it, and there's sort of that, that quid pro quo that exists between the consumer and the utility operator, right? So, and for a lot of people, I think the use of technology, of course, suggests that there is this phenomenal role that it can play. But for instance, I'll tell you, in the state of Uttar Pradesh, where we closely work, there was this recent problem where more than 200,000 smart meters were disconnected because of a breach in security, right? And all of a sudden, what ended up happening was, this massive loss in trust in what smart meters can actually do for these consumers, and that is something that you don't want, right? Where before you sort of establish the robustness of a system, you end up having these breaches, which then deteriorates what possibilities the system actually offers for you. So that, I think, is at the level of the consumer. I think where a lot of utilities have rolled out regulations and everything about smart meters, but I think this basic understanding of what it can do is missing, right? On the bulk side, right, I think one of the good things that India is trying to do, of course, I think while, of course, markets and I think the emerging technologies, whether it's, storage and synthetic inertia and all of that stuff that, electrochemical solutions offer, India is, of course, bent on pursuing what thermal power plants can actually offer. So if you've seen, the discussions which the the transmission system operators sort of really been driving, is how can you get this massive fleet of thermal generation stations to actually work like a balancing system for us, which I think the rest of the countries probably aren't doing as much. Of course, I think we know there are fantastic systems in Germany where the thermal power plant goes down to 10%. But I think even if you don't have that, given the integrated system that we have, if you can actually make it all work, nice and synchronously, we could probably get, tens of gigawatts worth of flexibility, right? Because the system already is interconnected. But I think what really is needed is the incentive for everybody to participate equally in that system. And I think that is where the challenge today in the country is. And I'll say this one example I think really is of thermal power plants that we have in the country today, right? The opportunity that India today has is of looking at thermal dispatch slightly differently from the rest of the world does, which is because there is this interlinkage between fuel markets as well as sort of the electricity market. And unfortunately, in India, they're not linked, in the sense that fuel markets are rigid. The supplies and everything are already pre-contracted. There's no way you can move around that supply. And if we were to actually sort of unleash some efficiency in that fuel market, mainly coal, if we're looking at a saving of potentially $3 billion, right, in just the fuel markets, avoided coal, right, dispatching efficient stations. Because today what's happening is that you don't have cheap fuel or the right level of fuel available to the right stations. So which means you've got cutting edge efficiency stations, which are like operating at like 30%, 35% PLFs, right, loads. And you've got like, old stations, which basically have got legacy fuel contracts, which are close to the pit head, which are operating at like 90%. And then you've got news articles which say, oh, a station did 42 years in service, and everybody's really proud of it. But unfortunately, that's a terrible station to be running, right? So I think there is of course innovation needed in that, but I think you also need to sort of figure out where can you get efficiency out of the system. And if we can do that, I think we can free up a lot of carbon space, right? But it's very difficult, and I think this is where that discussion of the just transition that I think is quite progressive in I think in the US and perhaps in the EU, right? Which I think is what a lot of people are saying that a country like India really needs to be sort of wary of, which is that if you are going to move away a lot of regions from coal-based dependency, right? Then what does it actually mean then for those areas that were dependent on the revenues for it? So I think that's where a lot of the discussion I think also is sort of stagnating, because we're not making meaningful progress in that. While we say that the electricity system needs to be decarbonized, we're not necessarily talking about whose benefits and whose gains. And as you can imagine, in India, it's a big equity issue, right? Decarbonizing the system at the cost of many local communities that benefit from coal and its royalties and the associated businesses means that we can't make that transition as easily as it is. It's already a very inequitable system, and I think if we decarbonize very fast, we basically end up making it worse for a lot of those communities. So that's another added element. I know it doesn't necessarily speak to the technology angle that we've been speaking about here. I think if we bring that into focus, we might do a lot better at understanding what the barriers are to enabling this transition itself. Yeah. Thanks.
Thank you, Kartik, for that perspective. I think you bring absolutely essential points. We've talked about technology. We talked a bit about regulation, touched the surface there, and bringing in the just transition that's needed, and also the security aspects of cybersecurity, as well as traditional security for electricity, because it's becoming more central to energy systems. This is absolutely critical. So I look at the clock and I see we're running near the end of time. I have one more question that I would like to ask everyone, and so give me 1 second to think about it, is a particular aspect on regulation or market design that you think would be an essential stepping stone to where we want to get. I'll give you 1 minute to think about that. In the meantime, I would like to bring in Yasmin to follow up on this point that Kartik raised on legacy coal issues, and to give us a global perspective on what we're talking about there and what are some of the challenges related to that.
Yes, indeed. It was very interesting, Kartik, that you raised that point of tackling the existing system in parallel of the expansion of new technology for decarbonization. I mean, coal plants, for instance, existing coal plants are the largest emitter of CO2 emission today, about a third. And this is because we have about 2,000 gigawatts of coal power plants today. and something like 130 also under construction. And this fleet is young. It's here with us for decades to come. And so these emissions are also here with us for decades to come. And this is a big challenge because this year we did this analysis, very detailed, on what would happen if the existing system, these coal plants, these vehicles on the roads would operate as in the past. And what is a very strong message is that it would already lock in over 700 gigaton of CO2 over the outlook. And what does it mean? It means that it would lead to a temperature raise of 1.65 degrees. So just the existing infrastructure put at risk all our climate goals. So that's very strong and very happy you raised, Kartik, this issue of the existing system.
Thank you, Yasmin. Certainly a sobering point. I think when we dig deep into that analysis, I mean, it reinforces the challenge that we not only need to focus on what we're building new, but how to address that system that we already have built, as you mentioned, as Kartik mentioned. So as I give you, I'll go with a quick hit here then on the market design question. So we'll just go 1, 2, 3 for our panelists, give you a few seconds each of what do you think a market design change or a key element that would help enable and be a stepping stone towards these clean energy futures? I'll start with Doug Arendt, please, if you have any thoughts.
Yeah, thanks, Brent. Very quickly, design away from quantitative goals, i.e. installed capacity, to energy and the services that are needed from those energy resources. Just succinctly to say that. There's a lot to unpack in that, but that's the succinct way I think that I can express that.
That's great, Doug. Thanks. I think that's, yeah, absolutely. We focus on what's built and rather the service or the end product of how much it means in the contribution. So,
yeah.
Great. Kartik, you had a speech on market design.
Right. Well, tough question, but I think I'll go back to the point that I raised earlier, which is basically trying, at least in economies like India, or perhaps even countries which are, coal rich, right, which are suppliers of coal. I would think that if you have legacy assets, right, how do you basically have a market that compensates, right, coal assets for being decommissioned more proactively, right? I think, the scheme that we had perhaps in Germany, where, where the German government declared that somebody like E.ON would basically phase out nuclear in 2022, I think is a fantastic situation. But I think given the way the markets here are structured, it's not easy to basically have a diktat there that works across the board, right? Which means that, so can we figure out a way of passing revenues from electricity markets to entities that will end up not operating, right? And I think it's not necessarily just a market question, but I think of revenues flowing to those entities that end up getting decommissioned, I think is something that India needs to think about very actively if we are to sort of save on all of that carbon that Yasmin brought up. Yeah.
Thanks, Kartik. It's your floor. Dr. Kreuzl, and for you on grids, is there a key point you would make?
Yeah, there is, and I'm very happy that there has been said so much already about what we would call the energy market and market design. I agree with that, so I don't need to repeat it, and can focus on the grids where we have a special stake in. And if you look at regulation of networks, then as I said that before, it used to be focusing on efficiency, which basically means cost efficiency and quality of service. And you may say that's focusing on the present, and if you look at the cost, also a lot on the past, but it doesn't look at the future, what we expect on networks from in future. And as long as you are not in a transition, that doesn't matter. But we are in a transition now, and therefore regulation of networks needs to be completed by a third pillar, I would say. Beyond efficiency, we still want to have efficiency and quality of service, no doubt. But we also need to have a forward-looking view at them, what functionalities we want to see in future in order to be ready once they are there. Networks are facilitators of what's happening around them. They are not a purpose in itself. So they have to facilitate the right things. And I would like to refer to what Doug mentioned before. Do we want to have, he didn't say smart charging, but managed charging or not? I think there is no doubt that in demand response mechanisms, and smart charging is also demand response, would help. But if you want to have that, we should think about what infrastructure do we need in order to make that happen before we roll out the cars. And we have done it the other way around. And I have to say again, so that's, we need a discussion, what functionalities do we want to have by this facilitating infrastructure, and what do we need to roll out for that proactively? Because doing it reactively, as we do until today, is usually it's more inefficient. Very simple. It's not because we want to sell great technologies. Of course we do. It is because we want to have a more efficient approach. Think about what functionalities we want. So this is the third pillar to be added to network regulation, completing efficiency and quality focus.
Perfect. Thank you, Dr. Kreisel. I think what I hear is very much that for the clean energy transitions to happen, we need them to be secure, reliable, affordable, and we need many different pieces of the puzzle coming together from a technology side. Innovations are coming that's not only in power generation, but also in grids. We need the intelligent infrastructure to actually manage all these pieces in an increasingly distributed system. What I hear, at least as an analyst, is that there's a lot more work to be done. And we have our job cut out for us, but that electricity can be on this leading edge for clean energy transitions around the world. And I think it's quite exciting. We, of course, with 1 hour, we did not manage to cover all of the topics that were, I saw questions coming in on hydropower, on nuclear power, on offshore wind and other technologies. These, of course, are all central. And I think a general point there is that we see the need for the widest set of clean energy technologies to be accessible so that everyone around the world has access to those methods to clean energy transitions, that it can be the most just and cost-effective for everyone around the world. So I think with that, we're running over, so I will close the session here. I'd first like to thank our panelists for joining us today from the United States, very early, India and Germany, and providing very important insights. I'd like to thank my WEO colleagues who presented highlights of the WEO 2020 Electricity Outlook, and to all those behind the scenes who contributed to the WEO electricity analysis this year, which is about a dozen people. And I'd also like to thank Laura Coetzee, the IEA Chief Energy Modeler and our manager, for her invaluable guidance and leadership along the way throughout the year. And thanks to all those who followed live today and submitted questions. I hope you enjoyed the discussion. We covered many aspects. And of course, there's always more to talk about on electricity and the wider energy systems. I'd like to remind you that this is the second day of WEO Week, with sessions in the coming days focused on the outlook for fuels tomorrow, getting to net zero emissions on Thursday, and on Friday, we'll be investing in the clean energy transitions that wraps together and pulls from all of these presentations and discussion. And we hope you find the WEO Week informative to give you some deep dives on these key aspects. And of course, as you see, you go down one layer, there are always many more layers to keep digging in, many more aspects. So with that, thank you very much, and I'd like to close here.